In a park courtyard, a small weighted object rises into the air. It is not a ball, and it is not a bird. It is a jianzi, the traditional Chinese shuttlecock, kicked upward by a player's foot. No matter how it tumbles at first, it usually returns to one familiar position, the feathers above, the weighted base below. The same strange design appears in badminton. A shuttlecock is not smooth like a tennis ball. It is not shaped to fly fast. In fact, it is built to slow down. Around its base sits a skirt of feathers or plastic spreading wide into the air. That seems inefficient until we ask the real question, why do shuttlecocks and jianzi need feathers at all? The answer begins with stability. When an object flies through air, gravity pulls on its mass, while air resistance pushes against its surface. If the object is perfectly symmetrical, like a smooth ball, it may spin, drift, or continue in many possible orientations. But a feathered shuttlecock is not symmetrical in the same way. Most of its mass is concentrated in the small, heavy base. Most of its air resistance is concentrated in the wide, feathered end. This separation creates a self-correcting motion. If the shuttlecock tilts sideways, the air pushes strongly on the feathers. Because the feathers are behind the heavy base, this push produces a turning effect called a torque. The torque rotates the shuttlecock back until the heavy end points forward and downward, and the feathered end trails behind. In simple language, the shuttlecock behaves like a tiny weather vane. The heavy nose leads. The wide tail catches the air. Any sideways mistake is corrected by the airflow itself. The feathers also increase drag. That means the shuttlecock slows down quickly after being hit. This is why a badminton shuttlecock can leave the racket at very high speed, yet lose speed dramatically within a short distance. It is not designed simply to travel far. It is designed to fly in a predictable, playable way. The same principle appears in arrows. The arrowhead is heavy, but the feathers at the back provide aerodynamic stability. If the arrow begins to yaw or wobble, air resistance on the feathers pulls it back into line. Rockets use fins for a similar reason. Many bombs and projectiles use tail fins. Even some plant seeds use wing-like shapes to control their fall. A common mistake is to think the feathers are there mainly to make the object float. That is not quite right. The key is not just lift. The key is drag arranged in the right place. The feathers place the center of air resistance behind the center of mass. That creates a restoring torque, and the object naturally points into stable flight. So the jianzi is more than a toy. It is a small lesson in aerodynamics. Long before modern laboratories, people discovered through play that feathers could tame the air. A simple kick sends it spinning upward, but the invisible force of air brings it back into order. The feathered shuttlecock teaches a quiet rule of flight. Speed matters, but stability matters more. To move through air reliably, an object must not only be pushed forward, it must also know how to correct itself.